Welcome to The Explainer. So you've got this awesome large language model app running on your own machine. That's fantastic. But now comes the real challenge. How do you take that from a cool solo project to a powerful service that your entire team can rely on in the cloud? Today, we're going to lay out the exact roadmap for that.
Okay, so here's our game plan. First, we'll talk about why scaling is so tough. Then, we'll look at the tools you're probably using right now, the easy local stuff. After that, we'll jump into the production-grade solution, something called vLLM, and put it head-to-head with the local tools, using some real data. And finally, we'll wrap it all up with a clear guide to help you make the right choice.
All right, so this is the question, right? This is the big jump that almost everyone hits. It's one thing to have a model working for you, but it's a completely different ballgame to build a robust, reliable service that can handle 10, 20, maybe even hundreds of people hitting it all at once.
I mean, think about it. Serving one person is pretty straightforward, but supporting a whole team? You've got developers who need coding assistance, data scientists running complex analysis, maybe even your finance and HR teams generating reports or querying documents. All these agentic tasks happening at the same time, well, that requires a whole different way of thinking about your architecture. And that's where the real fun begins.
So where does this journey usually start? Well, it starts with the local champions. And a great way to think about these tools is as the sports cars of LLM inference. You know, they're super fast, they're agile, and they're just perfect when it's just you, the developer, behind the wheel.
On one side, you've got Ollama. People often say it's like Docker for LLMs, and for good reason. It's incredibly simple to get a model up and running. And then, on the other side, you've got llama.cpp, which is the powerful C++ engine that Ollama is actually built on. With that, you get total control and just raw, unfiltered performance.
And this table really lays out the trade-off perfectly, doesn't it? With llama.cpp, you get the absolute best single-user performance, and it runs on practically anything. But with Ollama, you get that zero-friction, one-click setup that lets you start prototyping and building in minutes. It's all about speed of development versus raw power.
And look, this quote from the developer community just nails it. It perfectly sums up the whole limitation. These tools are sports cars. They are incredible for a single driver on an open road. But they were never, ever designed to be the team bus.
So you might be asking, why don't they scale? Well, it boils down to this. They handle requests one after another. It creates this thing called head-of-line blocking. It's like being in a single-file line at a coffee shop. You can't get your order until everyone in front of you is done. And when you have a bunch of users, those wait times just explode. Okay, so if the sports car isn't going to cut it, we need a totally different kind of vehicle. So let's bring in the bullet train. This is a system that's been engineered from the ground up for massive speed, huge capacity, and serving tons of people all at once.
And that bullet train is called vLLM. It's a high-performance inference engine that came out of UC Berkeley. Now, its goal was never to be simple. Its one and only goal was to solve this multi-user scaling problem and to squeeze every single bit of performance out of those really expensive data center GPUs.
Okay, to really get why vLLM is such a game changer, you have to understand the problem it was built to solve. You see, traditional engines are unbelievably wasteful with GPU memory, especially when they're handling a conversation's history, which is called the KV cache.
In fact, get this. A staggering 60 to 80% of that super valuable GPU memory is often just sitting there, reserved but totally unused. It's just wasted space. And that waste directly limits how many users you can serve, which hits your cloud bill hard and tanks your user experience.
So, vLLM's big breakthrough is this brilliant algorithm called paged attention. It completely throws out that wasteful old model. Instead, it treats GPU memory just like a modern computer's operating system does, allocating little blocks only when they're needed. This totally eliminates waste and lets you pack way more users onto the very same hardware.
And it combines that with another trick called continuous batching. Basically, this just makes sure the GPU never stops working. New users don't have to wait in a long line. It's like a ski lift that's always moving. You can just hop on anytime and get an answer almost instantly.
Now, these features are basically superpowers for those complex agentic workflows we talked about. You can serve different, custom-tuned models to different teams, one for coding, one for finance, all at the same time. And you can guarantee that when the model needs to call an external tool, its output is perfectly structured 100% of the time.
Okay, so that's the theory. Talk is cheap, right? Let's look at the actual data. Let's see what happens when we put these systems head-to-head on some serious
enterprise-grade hardware. The difference is, well, it's pretty dramatic.
Whoa, okay, just look at this. We're on a powerful NVIDIA H200 GPU with 64 people trying to use it at once. Look at the difference in requests per second. vLLM isn't just a little bit better, it's in a completely different universe.
And it's the exact same story when you look at the total output, the raw generative power. vLLM's architecture is just built to thrive under pressure. The more load you throw at it, the more it scales up. Meanwhile, llama.cpp just hits a wall.
Just let that number sink in for a second. That's not 35% better. It's over 35 times more throughput. That is the incredible power you get from an architecture that was designed for concurrency from day one.
Now this slide is maybe the most important one. Look at that last column, time to first token. That's how long a user has to stare at a blank screen before they see the first word of a response. With vLLM, it stays super fast, under 100 milliseconds. Now, look at llama.cpp under load. Over 15,000 milliseconds. That's a 15-second wait. That's that sequential queuing we talked about. And for user, that's just an eternity.
So, with all of this data, how do you actually make the right call for your project? The key is to realize it's not about which tool is the best, it's about which tool is the right one for your specific goal at your specific stage.
And this decision matrix makes it crystal clear. If you're just messing around on your laptop prototyping an idea, Ollama is perfect. If you need to run a model on a tiny embedded device, llama.cpp is your only choice. But the second you need to serve a team, even just a few people, and especially for a production service with 10 or more users, the path leads straight to vLLM.
So the big takeaway here is to stop thinking of these tools as competitors. They're not. They are complementary parts of a modern AI toolkit. Each one is a champion in its own domain, built for a specific leg of the journey from your laptop to a global scale API.
So in the end, it's about matching the right tool to the right job. You use the sports car for those first few creative sprints, and you bring in the bullet train when it's time to carry a crowd. If you choose correctly, you'll make sure your application isn't just powerful today, but that it's also scalable and ready for whatever comes next. So, you've seen the map. Which path is your AI service going to take?